All right, we're to determine, example 19, the modulus and argument of the complex number z. All right, so z plus I is in the first quadrant. The mod of z is equal to the square root of 3 squared plus 1 squared. So 3 squared is what? 9. 1 squared is 1. So this is the square root of 10. Now, the argument of z is theta is equal to tan inverse real first, 1 over 3, real over, imagine over real. The point 3, 1 is in the first quadrant. So the argument is just tan inverse. So theta is equal to, enter your calculator is in radians. So it's shift tan, open bracket, 1 divided by 3, close bracket, and press equal. So what I got is 0.322, sorry, all right, that is force of habit, 0.322 radians. All right, so the complex number z, which is 3 plus I, can be written as the root of 10, which is r, open bracket, the cosine of 0.322 plus I sine 0.322. That's what it is.
So I'm almost incapable of working this out because the calculator I don't have is keep on saying syntax errors. So I probably have to
Calculator
get
is saying you are saying syntax error when you try to do tan inverse 1 over 3.
Yes, sir.
You should throw away the calculator. I'm joking. I don't know, but it shouldn't, because tan inverse, did you use the brackets?
Yes, sir.
You should not get a syntax error, and you are 100% sure it's on radians?
Yes, sir. It's on radians. When it's
All right.
not on radians, it gives me 18
No.
point something.
Okay. Put it on radians and try it again. All right, example 20 says determine the modulus and argument of the complex number z. So let's go for modulus, and we're to express it in polar form. So the modulus r of z is equal to the square root of -2 square plus 1 square. So this is the square root of 5, and the argument of z, theta, is equal to -2, 1. -2, 1 is the second quadrant. So it's equal to pi plus tan inverse, real part first, 1 divided by -2. So let's put this in our calculator. Shift pi plus shift again, tan inverse, tan, open bracket, 1 divided by -2, close bracket, then press equal. This says 2.678. All right, radians. So it means therefore that the complex number z, which is -2 plus I, can be written as the square root of 5 into the cosine of 2.678 plus I sine 2.678. All right, example 21 next, guys. All right, so example 21, All right, so let's go where to write the complex numbers in polar format. So let's go for the modulus R is equal to the square root of 1 square plus root 3 square. So this is going to be the square root of 1 plus 3. Now, root 3 square means root 3 multiplied by root 3, which is 3. So this is the square root of 4, which is 2. The argument of Z, this is first quadrant, so it's equal to tan inverse the real part, which is root 3. Sorry, the imaginary part, which is root 3, over the real part, which is 1. So I'm searching my mind's eye now. The tan of which angle is root 3. Tan inverse root 3 will give a which angle. I'm just searching my mind's eye. Tan is opposite, so this is 60 degrees. Tan is opposite over adjacent, so this is 60 degrees. So this is 60 degrees or pi by 3. So it means therefore that the complex number 1 plus I root 3 would be equal to 2 into the cosine of pi by 3 plus I sine pi by 3. All right, that's what I have. Let us do the second one, which looked like something we did already. R is equal to the square root of 1 square plus minus 1 square. This is the square root of 2. Now the argument of Z theta, which is theta, is, now this is 1 minus 1. That looks to me like it is the 1 minus 1 is the fourth quadrant. So it's just tan inverse imaginary first. So this is minus 1 over the real 1. So this is minus pi by 4. So the complex number 1 minus I is equal to the root of 2 into the cosine of minus pi by 4 plus I sine minus pi by 4. Now let's go for C. For C, R is equal to the square root of minus 1 square plus minus 1 square. So this is the same as the root of 2. The argument of Z theta would be equal to, now minus 1 minus I, that is the third quadrant. So this is equal to minus pi plus tan inverse minus 1 over minus 1. So this is going to be equal to minus pi plus pi by 4, which is minus 3 pi by 4. So it means therefore that minus 1 minus I is equal to the root of 2, the cosine of minus 3 pi by 4 plus I sine minus 3 pi by 4. Turning the page to look at D. For D, the modulus R is equal to the square root of minus 3 root 3, which is the real part, square, plus minus 3 square, which is the imaginary part. So if I square this, this becomes the root of 3 square is 9. So this is 9 multiplied by root 3 square, which is 3 plus 9. 3 nines are 27. So this is 27 plus 9. This is the root of 36, which is 6. Now, the argument of Z, which is theta, is equal to, all right, so minus 3, minus is, again, third quadrant. So this is minus pi plus tan inverse 3 minus 3 imaginary over minus 3 root 3 real. The 3 here cancels the 3. So this becomes minus pi plus tan inverse 1 over root 3, because a negative divided by a negative is a positive. Now I'm searching my mind's eye. The tan of which angle is minus is 1 over root 3. 1, that is 30 degrees. So this is minus pi plus pi by 6. 30 degrees is pi by 6. So this is minus 5 pi by 6. So the complex number minus 3 root 3 minus 3i can be written as 6 into the cosine of minus 5 pi by 6 plus I sine minus 5 pi by 6. All right, and that would be the end of example 21.